Now we're going to start talking about graphically displaying quantitative data. This is where we're really going to spend some time. So previously on qualitative data, we looked at dot plots, box plots, and we could talk a little bit about how spread out or consistent the data was, but there wasn't much we could really do with it. For visually looking at quantitative data, the main two displays are stem plots and histograms. Now we're looking at the shapes of these. There's a few things that we're going to look at. The location, and this is mainly talking about the center. So the measure of center is going to be very, very important. The spread is going to be the next one. How spread out the data is. And we'll learn how to find those summary variables, such as for center, median, mean. For spread, it's going to be range, IQR, standard deviation. We're also going to talk about the shape of the data. Are the values clumped together? Are they uniform? Are they leaning to one side or to the other? Do we have outliers? Do we have data points that aren't consistent with the rest of the data? So we're going to start with the shape because that's the easiest. So when we're looking at the shape, one way you could have the shape is that it could be completely symmetrical. So you have the center and everything just looks like perfect, a bell curve type thing. We could have data that are skewed. Values are more spread out on one side of the center than on the other. And the two ways it could be skewed to the right, or right skewed, or left skewed. So right skewed means the tail extends to the right. So this is right skewed. The majority of your data is here, and then you have this section that's sticking out to the right. Left skewed says you have most of your data here, but you've got this section sticking out to the left. So it's wherever the tail is that tells you which way you're skewed. Now let's talk a little bit about vocabulary. A histogram is sort of like a bar graph. And the bars have to be equal width. And a bar graph, let me show a difference. Compared to so a bar graph, your bars were separate. In a histogram, they touch. Now the horizontal scale represents the classes of quantitative data values, so the horizontal scale, and the vertical scale is going to represent frequencies. The heights of the bars are going to be their frequency values, just like you had with bar graphs. Now the strengths of these, they are great tools for judging the shape, wonderful for moderate and large size sample space sizes. The weaknesses with a small sample size, it's not really good for small sample sizes, but it's great for moderate to large. A histogram is not the same as a bar graph. A histogram displays the distribution of a quantitative variable, whereas a bar graph is for a qualitative. So let's make sure we note that. Histogram is for quantitative. Bar graph goes for qualitative. Now, while the bar graph was easier to do by hand, histograms tend to be much easier to construct with technology. It's easy to confuse the skewness to the right or to the left. So just remember the direction of the skew is indicated by the tail. The tail tells you. The tail will tell you. Okay. An experiment was conducted in which 2 fair die were thrown 100 times. The sum of the dots showing on the dice was recorded. The following frequency histogram gives the results. So they got a sum of 4 that many times, a sum of 5, 6. And remember, they threw these dice 100 times. What was the most frequent outcome of the experiment? So which one of the sums occurred the most? Well, it would be this one. It's the sum of 8. Which was the least occurring? Sum of 2. And that kind of makes sense because the only way to get a 2 is a 1 and a 1. How many times did we observe a 7? Well, that's 15. How many more 5s were observed than 4s? So let's kind of guesstimate here. 5s is just a little bit above 10, so I'm going to guess this is like an 11. 4s, it's not directly above the 5, so I'm going to guess this is like a 7. So how many more 5s than 4s? I'm going to guess that would be about 4. Determine the percentage of time a 7 was observed. So 7 was 15 times out of how many rolls? 100, so that would be 15%. Describe the shape. So if I kind of followed this, notice that the majority of the data is over here, and then we've got this tail sticking off on the left side. So I would say this is slightly left skewed. A car salesman records the number of cars he sold each week for the past year. The following frequency shows the results. What is the most frequent number of cars sold in a week? Now that's easy. That's the tallest one. That's 4. For how many weeks were 2 cars sold? That's 9. Determine the percentage of time 2 cars were sold. So that was 9 out of, and this was for a whole year, so 9 out of 52. 0.173. But what is that as a percent? That'd be 17.3%. Describe the shape. Do we have a tail? We do. We have a tail over here. This would be right skewed. The following numbers are sample of quiz grades taken from the 600 students at Olympia High School taking statistics. Construct a frequency distribution that has 7 classes. So we need to talk about how to find the class width. To find the class width, the way we're going to do that is we're going to take the max minus the minimum divided by the number of classes we want. So let's see if we can find the maximum grade. What is the largest grade in this list? So take a moment, look through the list. I think it's this 96. Minus the minimum Oh boy, somebody made a 17. Divided by, we want 7 classes. Okay. So 96 minus 17 is 79. Divided by 7 is going to be 11.29. Now, having a class of 11.29 just doesn't make sense. So we're going to round up. So my class width is going to be 12. That means we're going to start with our minimum of 17. The next class is going to start 12 up from there. So this is going to start at 29. So for each class, I'm adding 12. So from here to here, this is plus 12. Plus 12. So the next class would start at plus 12 would be 41, 53, 65, 77, and then this would be an 89. So if this class starts at 17 and the next one begins at 29, where does this one end? Well, it ends at 28. And if you notice, this other side is actually going up by 12s as well. It ends up working out perfectly. Now when it says tally, that means we're going to go through and count all the scores that are between 17 and 28. So an easy way to do that is to go through and mark the ones that are between 17 and 28 and count them as you do. I find that helpful. So 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6. So 6 of those. Now some people like to just tally as they go, so they would mark 60 and put it where it goes. It's up to you, personal preference. So you can kind of pause if you want, count these up, and then we can double check our numbers when you go. I'm going to go ahead and fill in my counts. Once you have your counts, your frequencies are what go on the vertical y-axis. So 1, 2, 3, 4, 5, 6. I'm sorry that these are 7, 8. These are light. 9, 10, 11, 12, 13. Now I don't really want to count all the way to 100 here. But because we made these of equal width, I don't really have to, and I'll show you what I mean by that. So I'm going to start this at 17, and the next one's going to start at 29 or whatever. And so 1, 2, 3, 4, 5, 6, 7 with it ending at 100. And because I skipped some spaces, if you do this zigzag, that shows people that we're not starting at 1. We're skipping some spaces. Now 17 to 28 had a frequency of 6, so it goes up here, there, and then back down. The next class had a frequency of 10. Then we had a frequency of 13. A frequency of 8. 10, 9, 8. The next class had a frequency of 5. 6. And then 2. So how would you describe this graph? Well, I would describe it as maybe right skewed, because it has a little tail on the end. Now we can also make our graphs using relative frequencies. The relative frequency is just the proportion or percentage instead of using the frequencies. We could do the percentages instead. We could also make what is called the cumulative frequency graph. And that would be the sum of the frequencies as we go up. So we're going to kind of play with both of those with one group. So this is a table that lists the frequencies of the amount of cash each student had in his or her pocket. So 5 people had between $0 and $4, 3 people had between $5 and $9, and so forth. So if I was talking about, first off, let's ask the question, what's the class width here? How wide is each class? Well, 0 to 5, so the class width is 5. How many classes do I have? 1, 2, 3, 4, 5. So 6 classes. That's good things to notice. Okay. Let's see what the regular frequency histogram would look like. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I don't know why I switched to color when I was doing everything else in black and white. And like I said, we can say that this is starting at 5, 10, 15, 20, 25, and that would be 30. Okay. So the first from 0 to 4, it goes up to 5, and the next one goes to 3, it goes up to 8, then 6, then all the way to 10, and then 7. While we're here, I want to just kind of bring up something. this one, it's not as symmetrical as some of the other ones we've seen. We do have one that is occurring the most. This is called the mode. It occurs the most. Just making sure we bring that up occasionally. Relative frequencies. This just means that we're going to have our, instead of frequency on our y-axis, this is just the percentages instead. So to do the percentages, I need to know my total frequency. So if I added these all up, 5 plus 3 plus 8 plus 6 plus 10 plus 7, that's 39. So to find my relative frequency, that's going to be 5 out of 39, 3 out of 39, 8 out of 39, 6 out of 39, 10 out of 39, and 7 out of 39. The percentage. So 5 out of 39, I got 12 point, so that'd be 12.8%. 3 out of 39 is that'd be 7.7%. That's 20.5%, basically 15.4. Whoops. What did I do there? I don't know what I was doing. Oh, I was looking at my key and I wrote down the percent instead. Okay. So we will have the same classes, right? But on this, we're going to be having percents. So maybe I count by, sorry about that. I'm going to count like 2%, 4%, 6%, 8%, 10%. Okay, so the first group is 12.8, so that would be about here, and then 7.7 would be almost 8%, and then 20.5 would just be a little bit past that, 15.4, let's see, 12, 14, 16, so in between there. 25, so 20, 22, 24, 26. And then this would be around 18. What do you notice about the two histograms? So here's my percentages. And this was just the frequencies. They're basically the same exact shape, right? You still got the same class, that's the mode. You can still tell which one's highest, which one's lowest. You can still see the same shape. So relative frequency graphs and frequency, histograms and frequency histograms tend to look exactly the same. Now, cumulative frequencies are very, very different. So we're going to do one of those. And cumulative means you have a running total. So running total. So in this first group, we've counted 5, right? By the time we get to the second group, we had counted 5, then we counted 3 more. So 5 plus 3, we're now at 8. We're going to take that last total and add to it another 8. So 8 plus 8, we're now at 16. Plus 6 is 22. Plus 10 is 32. Plus 7 is 39. Now we're going to make a cumulative frequency graph with that data. So on this one, so the frequency is here, and this is actually the cumulative frequency. And this is my classes still here. So we still have the class of 0 to 4. I'm going to give myself a little space here. 0 to 4, 5 to 9, 10 to 14, 15 to 19, 20 to 24. And the last class was 25 to 29. And to get all the way to 39, I might have to count by 2s again. So 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26, 28, 30, 32, 34, 36, 38, 40. I almost ran out of room. Okay, so when we start counting, we always start at 0. Now, when we got to the end of the first class, our running total was at a 5. So 2, 4, 5. When we got to the end of the second class, our running total was up to an 8. By the end of the next group, we were at 16. So 10, 12, 14, 16. By the end of the next group, we were up to 22. By the end of the next group, I was at 32. Okay, so I'm going to have to kind of... Mine's really, really light. My copies were not so great. All right. 32, and then by the end of the last one, we're at 39. And we're going to play connect the dots. What this tells me is where I have my biggest increases and where I have my smallest increases. So notice in this class we really didn't increase that much. This is the smallest increase. Where did I increase the most? Well, see how steep this line is? This is the largest increase. There's other useful things we can find from the cumulative frequency graphs, but for right now, that's where we're going.